Now friends, we are in the third quarter, Kinematics, exploring perplex numbers. Here I am going to follow the Russian authors' approach, Landau and Lifshitz, which they have used for 4 vectors, and implementing that approach of 4 vectors for perplex numbers. This is the already known thing for 4 vectors, but this is being applied for the first time to perplex number. That is the novelty. Let us consider we have 2 usual frames S and S dash, and they form a pair of inertial frames of references. As usual, S is a stationary frame of reference wherein we are locating ourselves, and S dash is an inertial frame which is moving along x direction, or in this case r direction, with uniform velocity v. Under this pretext, let us define an event for an observer in S and for an observer in S dash. The events being represented 2 letters Z and Z dash for 2 observers are not different. It is one and the same. So you can take liberty to equate Z and Z dash for being physically the same. Z is equal to Ct plus Rj, perplex number where j is equal to -1, and Z dash is Ct dash plus R dash j. Here velocity of light is absolute for observer in S and S dash, which is second hypothesis of Einstein's special theory of relativity. It has been taken care of duly. Now the infinitesimal variation over the 2 events, which is separated by a infinitesimal distance dr and infinitesimal non-zero time interval dt, can be represented by definition as dz equal to c dt plus dr times j. Similar is for observer in S dash. The magnitude of the perplex number dz and dz dash has to be identical. That is claimed by equation number 30. Now we impose that the event occurring in frame S dash is at location O dash, that is origin of that coordinate system, so that the variation dr dash is 0. By virtue of that, we can compare the magnitudes of 2 numbers as appearing in the next equation. C square dt square minus dr square is equal to c square dt dash square. Now we can rearrange this equation wherein we can write tau for t dash and substitute dr by dt, velocity, which is obviously a function of time, and velocity upon c will be relative velocity beta, obviously function of time, and we define gamma is equal to 1 upon under root of 1 minus beta square, the usual definition that we are carrying further. So you can rearrange the last equation to obtain equation number 31, which is dt by d tau equal to gamma, in fact equal to 1 upon under root of 1 minus beta square. So the Lorentz factor gamma is appearing here, which is the rate at which the time t changes with respect to proper time tau, when the velocity involved between 2 observers or 2 frames S and S dash is v. Now we are in position to redefine our kinematical parameters with a name: perplex position, perplex velocity, perplex momentum, perplex force, and perplex energy. In fact, we are not having perplex energy here, but we are going to have usual energy from perplex momentum. And it would be most fascinating that how quickly we descend to the equations of relativity in terms of energy. Here, using proper time tau to differentiate, as it is the universal quantity for all inertial observers. And when you want to differentiate with respect to tau, you encounter with a chain rule where you come across dt by d tau, which is in fact gamma. Let us redefine all quantities in terms of relativity and events. Z can be represented by three ways: a pair of quantities Ct and R, which you can call ordered pair, that can be represented in form of a 2 by 2 matrix or simply 2 by 1 matrix. And the same quantity can be represented by Euler representation mod of Z e to the power j phi. Its complex conjugate is in the second equation. Now the modulus or length of Z is denoted by determinant Z or mod Z, that can be expressed as equation number 33, which we have already done in terms of x, y or ab. So under root of mod of z star is equal to mod of z equal to mod of z star equal to c square t square minus r square, which is interval in special relativity, and the Euler angle phi is hyperbolic tan inverse of r upon ct. The product zz star you can obtain by multiplication of two matrices as shown in equation number 34, and that leads to a real quantity where the imaginary component is vanishing, written here in terms of 0. So the ordered pair of zz star is interval square and 0. For the observer in frame S dash, we have the same event being represented by letter Z star is Lorentz transformation of Z. So you have to operate multiplication two matrices which are 2 by 2 in nature. So C T dash R dash R dash C T dash equal to the Lorentz transformation matrix gamma minus beta gamma gamma operated on CT R R CT. The moment you operate that, you encounter with what you have already defined as Lorentz transformation, and if you simplify the right hand side of equation 36 for magnitude of the number or length of the perplex number or mod of the number, you will encounter with the quantity c square t square minus r square whole square, which is in fact mod of zz star equal to mod of z dash star. The involved angle phi or phi dash you can define from the basic parameters, and here I have defined phi dash as u dash upon c. The dash is indicating quantities for observer in frame S dash. Now we are in position to define velocity using perplex numbers, and we shall be calling that as perplex velocity. To obtain perplex velocity, we need to differentiate perplex position with respect to proper time, which is a universal quantity as we have discussed for all inertial observers. So capital V is dz by d tau, and when we operate this differential operator on z, we are in fact operating it on ct plus rj. Now we have to explore the chain rule. dt by d tau is gamma as we have defined in the beginning, and dr by d tau can be written as dr by dt into dt upon d tau. So replacing dt upon d tau by gamma, we are left with gamma times dr by dt, which is in fact gamma times v. So we are done with the definition of perplex velocity, which will be gamma times c plus vj. So in equation 38, you can look at the traditional representation, you can identify the ordered pair, you can identify the matrix representation, which you can shrink to 2 by 1 matrix also, and you can choose to write mod of v into e to the power j times phi, where phi is tan h inverse of beta. So if you work out mod of this, where beta you can write V by C and gamma you can recollect it is 1 upon under root of 1 minus beta square. So if you simplify that, it turns C square. So velocity V is some quantity which is Lorentz invariant. C square is Lorentz invariant quantity, like the interval was appearing in terms of perplex position, and it only depends upon the angle phi, which is tan H inverse of beta. The whole story depends upon the orientation about the axis perpendicular to the perplex plane, that is determined by the relative velocity between two frames. Similarly, you can work out V star, and for V star you have ordered pair gamma C minus gamma V as appearing in equation number 39, where we are representing all other forms like determinant and Euler form. Now the complex conjugate we can write using with shorthand notation. We can have a 2 by 1 matrix so that we can consider it for multiplication, and if you work out V star, you will be able to obtain a determinant C square 0 0 C square, equation number 40, that contains only real part and the imaginary part is 0. Now if you like to operate Lorentz transformation on perplex velocity, you will be able to obtain V dash, and V dash appears as in equation 42 C 0 0 C. The invariance governing the equation mod V equal to mod V dash equal to C square is same for all inertial observers, which in fact is universal constant. Now the next definition that we are developing is momentum capital P using perplex numbers. This is a quantity of interest because this quantity is going to descend us to most important energy equations of special relativity very quickly, and in applications we are going to use conservation of momentum every now and then. That is why it is very, very important. Now perplex momentum is obtained by multiplying mass, which is in fact proper mass, which is same for all inertial observers, that is measured in the state of rest by every observer, times the perplex velocity. So P is equal to m0v. Just by multiplying the factor m0 in the earlier equation we can obtain perplex momentum, and the matrix version and Euler version is appearing in equation number 43. Here purposefully I have used alphabet phi1 for the Euler angle involved because I am going to use two forms of these equations. Similarly, P star is m0 V star, which is mod of P star e to the power minus j phi. Here mod of P star is essentially equal to under root of mod of PP star, which turns out to be m0 square C square if you operate the multiplication as desired. This quantity m0 C whole square is Lorentz invariant because by definition m0 is proper mass, that is identical for all inertial observers, and C is also identical for all inertial observers, being the valid second postulate of Einstein's special theory of relativity. And now if you work out the involved angle phi1, it is tan H inverse of y component upon x component, that turns out to be simply beta. Moreover, I would like to emphasize upon that m0 proper mass and the mass which is velocity dependent is related by the equation appearing at the end here as m equal to gamma times m0. Now the perplex momentum I am writing mcmv ordered pair. Similarly P star mc and minus mv ordered pair. So what I have done, I have used gamma m0 as m. Now here I am going to borrow the Einstein's famous equation E equal to mc square, and later on going to give you the evidence that this is already embedded in the equations we are handling. Now if we explore that E equal to mc square, we can write E by c equal to mc. So here I want to replace this mc by E by c, and m into v is the relativistic momentum that we define in special relativity. So the perplex momentum can now be relooked as ordered pair E upon c and p. Now you can look at the matrix version as well Euler's version, wherein the Euler angle I am saying phi 2, which is essentially equal to phi 1, but as we are defining in different notations, I have given the isolated name phi 1 and phi 2, and later on I am going to equate them. So similarly p star can also be defined, which is appearing in equation 47, and the mod of p, now if you work out, it is m0 square c square, which already we have worked in the earlier slide, m0 square c square, that is equal to a square minus b square. Here a is e upon c and b is p, so e square upon c square minus p square is equal to m0 square c square. So phi 1 and phi 2 being equal, you can take liberty to equate p upon e by c, which on simplification you can see pc upon e equal to beta. Now m0 square c square equal to e square upon c square minus p square is the same famous equation which you often call as relativistic energy of the particle, and if you simplify that equation for E, it will be p square c square plus m0 square c to the power whole thing in the under root. And if you simplify phi 1 equal to phi 2, which is in fact pc upon E equal to beta, if you like to write beta is equal to v by c, and the relativistic momentum p as m into v, you can come across E is equal to mc square. So we have descended to both the equations representing energy as appearing in equation number 49 from the definition of momentum, perplex momentum. Now the obvious relationship for the observer in frame S dash can be obtained using Lorentz transformations, and if you like to find P dash, which is in fact E dash upon C and P dash, it will be Lorentz transformation operated on 2 by 1 matrix E by C. So if you like to simplify that, you can obtain P dash in the expanded form as in equation 51, wherein the magnitude of the perplex number is E square upon C square minus P square into e to the power j times phi, where that phi is equal to tan h inverse of p minus beta e upon c divided by e upon c minus beta p. So p dash can also be written in the another form as the Lorentz matrix gamma minus beta gamma gamma multiplied by 2 by 1 matrix mc mv, or if you like m0 gamma c m0 gamma v. So simplifying right hand side of equation 52, one can obtain p dash as ordered pair m0c and 0, which in fact can be written as mod of p dash, which is m0 square c square e to the power j times tan h inverse of y upon x. So here the y quantity is 0, so we are left with tan h inverse of 0 as appearing in equation number 53. The most expanded version of the perplex momentum which we have defined here, P is equal to m0c upon under root of 1 minus v square by c square. The second element m0v upon under root of 1 minus v square by c square. So in the cross representation they are appearing in the second row, so I don't repeat that. Substituting m0c gamma after expanding by binomial expansion of 1 minus v square by c square to the power minus 1 by 2, we can write approximately as m0c plus 1 by 2 m0 v square into 1 by c. Here we are ignoring the higher order terms, and if you adjust c, we can write energy E equal to mc square equal to m0c square plus 1 by 2 m0 v square. So on right hand side of equation 55, the first part is rest energy and second part is the kinetic energy in frame S. Now we are in position to define perplex acceleration, and the things are getting weird immediately by second differentiation occurring here. So we shall precisely operate the differential operator dd tau on perplex velocity to obtain perplex acceleration. So it will be simply equation 56, right hand side depicts d dt operated on gamma c plus vj. Now the same chain rule we are going to explore again here, and if you simplify the whole stuff, you try to differentiate gamma with respect to tau, we obtain something gamma dot, and A is equal to gamma multiplied by, inside bracket we have C gamma dot plus the second term we have to operate chain rule d dt of gamma into V. So derivative of first into second quantity plus first quantity into derivative of second. So here I have conveniently used the term acceleration, which is usual acceleration that we consider in Newtonian mechanics. The equation 57 represents the acceleration definition. Thus, equation 58 depicts the ordered pair of acceleration is gamma gamma dot c and gamma times v gamma dot plus gamma square times. So the same thing can be represented in the matrix form as appearing on right hand side of equation 58. Note that gamma dot can be further simplified as beta a gamma cube c. So if you write gamma is equal to 1 upon under root of 1 minus beta square and differentiate that with respect to tau, you can obtain this quantity gamma dot equal to beta a gamma cube upon c. And if you substitute that in the previous equation 58, you can obtain A in the elegant way as ordered pair beta a gamma to the power 4 and a gamma to the power 4, which can be expressed in the form mod a e to the power j, where mod a can be minus a square gamma power 6. Here phi is equal to hyperbolic tan inverse of 1 upon beta. So here the situation is a little weird in the sense that the modulus of the number, that is length of the perplex number, is appearing negative, while phi is tan h inverse of beta. You very well know that beta is rolling from 0 to 1. 1 upon beta will roll from infinity to 1. So here we are entering into something nasty, or you can say complicated. Moreover, I want to mention that if you operate Lorentz transformation on A, you can obtain A dash, and A dash star is essentially equal to A star, which is equal to A square gamma to the power 6 whole square, which is Lorentz invariant. We can now explore the perplex acceleration under Lorentz transformation and rewrite that in a compact form as A dash, which is ordered pair of 0 a gamma to the power 3. In fact, if you find the mod of a and a dash, it is simply minus a square gamma to the power 6. Again here we encounter with negative length of the perplex number, and the angle phi blows by the function tan h inverse of infinity, because when we consider y upon x, we have to consider a gamma cube upon 0. Now friends, we are in position to define force using perplex numbers in special relativity, and by definition, perplex force will be the proper time rate of change of perplex momentum, and equation 62 depicts that definition. And again we have to use chain rule to make our differentiation with respect to tau into with respect to t by the factor gamma, and the force can be rewritten as in equation number 63. And if you like to represent that in the matrix form, the ordered pair in simplified version will be beta gamma to the power 4 m0a, where a is usual acceleration and m0 is the proper mass, and the another element of the ordered pair is gamma to the power 4 m0a. So you can locate mod of f e to the power j times tan h inverse of 1 upon beta. So the force, when we like to represent in form of Euler's representation, the mod f is operated here, and phi is also explored in terms of tan h inverse of 1 upon beta. One can very well write f dash using Lorentz transformation, and the equations are similarly rolling as they were rolling in perplex acceleration in S dash coordinate system, except the multiplying factor you will find m0 appearing in all equations. And similarly, the phi angle is blown up by the function tan h inverse of infinity. Now we are in position to explore the way to the Rindler force, which was given in the literature in 1966 by Rindler. At the end I have mentioned the paper by Rindler. So force by definition is the proper time rate of change of perplex momentum, and here this time momentum we are writing ordered pair E by C and relativistic momentum P. From mechanics we know dE by dt is F dot V, rather force into velocity, which is in fact m0 a dash V, and dP by dt is acceleration in relativistic term, and here I am using dash for acceleration so that it is m0 a dash. So the perplex force in the matrix form can be depicted as in equation 71, and on the right hand side we are showing up the Euler version of the same. F dash can be obtained by operating Lorentz transformation matrix multiplied by perplex force that is appearing in equation 72. Now if you compare equation 69, the last equation on this slide, and 72, you can write as a dash equal to gamma cube a, which was the finding of Rindler in 1966. So the perplex number representation also encompasses the Rindler space when we differentiate the whole stuff with respect to time, and there we are not considering the factor gamma as constant by definition. Beta is constant to make inertial frame. So when we consider acceleration, we drop away the definition of inertial frame, and gamma is function of time, and that leads us to the equation a dash, that is acceleration in frame S dash equal to gamma cube times acceleration in frame S.